All right, so this is a discussion to talk about a TimescaleDB proof of concept or demonstration. So with that wonderful introduction, I'll just hand it over to Nick and we can start talking about it. So Nick, you talked about during the database scalability working group, it'd be quite easy to put together a TimescaleDB proof of concept because we had not actually talked about using that for the time decay blueprint. So what are your thoughts?
Right. So for time series data, it's like timescale right now became like standard de facto in Postgres ecosystem, and more companies are using it, and it's been developed very well. So they implemented various interesting things related to compression of old data. They also released recent, like they have a lot of automation, for example. Automatic deletion of old chunks. They call it chunks, but it's basically partitions. So partition management, fully automated. They also have additional functionality like user-defined functions, like materialized views used to, for example, we can use it to track some counters or some aggregates. So they have a lot of functionality and it's improving. I was really impressed about their compression work. So it's like very interesting. They have good article I can send you. So like compression, you just can Google it. It was very deep and impressive material, and it's working. It's open source. They made last year, as I remember, they made decision to make everything open source, all functionality, and only require not to build cloud solutions based on timescale. So they decided to, unlike Citus, which distinguishes open source and enterprise version, Timescale decided to have all functionality in an open source version, but like they only say don't build. As I understand, maybe I'm not a lawyer and so on, but as I understand, they just forbid creation of cloud offering for time series data, like because they are building their own product. What else? We can easily check some table. I've said like we can check CI builds in its current shape. Okay, this I will send link to about compression to the chat here. Okay, not here. I see. So we can take CI builds, for example, and actually I already played a little bit with it with timescale for CI builds. I did it in database lab engine, so I just took a clone and checked various approaches how we can split table to chunks, so partition it basically with timescale. And I'm sending this like very quick and dirty proof of concept activity I did like several days ago here. It's in bad form and snippet, but you can see results and comments there. So interesting observation I had. Let me point you to some additional doc. I've checked. I was reading different materials about what to do with plans, what to do with CI builds, and I was curious how current workload to CI builds looks like, and also created this document, also sending to our Zoom chat. So let me share my screen also, and we will discuss it. So this is basically some dump of register statements for CI builds, ordered by calls in reverse order. And we see these queries, and I was manually checking. We can automate it, of course, and understand patterns here. But basically, some queries we have single lookup from primary. I'm sure other people already also did similar analysis, but just to be on the same page. So we have some queries which are basically primary key lookup based on ID, and many queries are searched by commit ID, which commit ID, as I understand, not commit ID, it's a pipeline ID, right? So ID of, because I see foreign key to pipelines table. So this commit ID is something special, as I understand, for when we work with CI builds. So that's why I decided in my experiments, I considered commit ID as time, because I don't see created at all here, right? So we cannot choose created as our time if we want to partition by time CI builds. I did very independent experiment. So just consider it as again some dirty data, the dirty proof of concept. So I use commit ID as our time because it's incrementally growing in time, and like lower commit ID means some old data, newer means like some newer data. So it's some integer, of course, right? And of course, timescale can work with both with timestamps and integers. People do it, and it's okay. Moreover,
what was the period of time for this?
Right. This is interesting. This is interesting. If we choose time, for example, we say we want months, then some old months will have much less data than new months, right? Because rates are increasing. If we choose commit ID, I took, I believe, 1 million as chunk size, chunk time interval. It's called time, but it's like because originally they created it for time, but integers also support it, so we need to ignore this word here. And I took 1 million, but I worked only with partial data. You see it here. I filled only with, I believe it's only 2 last months, like March and April, because it was already a lot. You can see a lot of data here. So after I did it, I checked some queries very briefly, and I saw, of course, if query includes our commit ID, it's quite fast. So insert approximate query. No, I don't have it here. Yeah, I will put it here, or where you want to discuss it, I can put it there as well. So I mean, if query has filter on commit ID, it's very fast, super fast. Of course, planning time is increased, but I believe the same problem we observed when we implemented custom partitioning. When we have a lot of partitions, first time we call a query, it has very big planning time. So this is a separate problem. We need to discuss it. There are some approaches to it, but it's dependent on the tool we use, like our own solution for partitioning or timescale. But second call and others were very well. Like I compared like querying original table and partition table with timescale. It worked. It worked well. Interesting thing. Additionally, we can use 2 dimensions for partition. It's like some thought towards sharding, because timescale 2 they also have sharding, and we can use not only time commit ID in our case, but also project ID. CI builds doesn't have namespace, so for dirty proof of concept, I used project ID, and I said we want to split it by three like big chunks, or how to say, 3 parts by project ID, and then shrink to chunks 1 million each. So it's like 2-dimensional partitioning. And additionally, I checked experiments for sharding. It was a little bit more difficult. So I had 3 shards based on project ID. Inside each, we had partitions of 1 million by commit ID. But it's already beyond this discussion. So I'm not going to advocate timescale for sharding. It's more difficult topic. But for partitioning, I see we could benefit from it if at least we need to explore it, because what they do, like it looks interesting, and like features they have, either we need to use them or we need to implement some features ourselves. So like basically, to me, honestly, it feels like if we do it ourselves, it looks like reinventing the wheel. The wheel already exists. A lot of engines, I mean, cars, companies already use this wheel. So that's why I feel it like around me, like a lot of companies are using it. So
can I ask a few questions, or Greg, do you want to speak first?
No, go
okay.
ahead, Janis.
So I was checking also TimescaleDB, and I'm trying to understand how it is going to help us now. So for example, we can do time-based partitioning. We have not worked with multi-dimensional partitioning, but we can discuss that, or we don't have this problem at the moment. So I'm trying to understand how TimescaleDB will help us with respect to, in general, compared to what we have right now. So for example, right now, we can partition by date intervals. Either way, we have to do the workload analysis. And to tell you the truth, the sheet that you shared with us is very interesting, because it shows, the workload over CI builds. So this is something that we should do either way. But other than that, how is TimescaleDB going to help us on top of using pure Postgres now that we have the tools?
yeah, excuse me, what did Sid show?
No, I mean, say about the spreadsheet. Yeah, I'm sorry.
Spreadsheet.
Yeah. The workload. Yeah. So what you did there, it's what we have to do either way, and
right.
This is very useful. But let's say that at some point we decide that we're going to use created.dat or commit ID or whatever.
Right. So as I've said, there are features they developed, but we didn't develop yet. Right. For example, do have some logic for automatic deletion of old partitions? Do have some logic to compress them automatically in the background? So implement compression. Do we have do we have? They have also, as I've called, it's called continuous aggregates. I'm looking at it right now. Continuous aggregates is like materialized views that are automatically maintained. And so fresh data is coming, and these views are automatically refreshed concurrently. So it's like some additional helper mechanism that helps you have aggregates pre-calculated. Then they have user-defined actions. So it's like background jobs on chunks. Not sure it's needed because we have our own background system. Then automatic reordering data in chunks physically by index. It's kind of cluster for Postgres, but for chunks only. So they have these features to work with very large volumes of data. As I've said, like the most noticeable here is compression for me. Like I really impressed with it, and the automatic deletion of chunks. It's working very well. That's it. But if you see we can develop everything or we don't need it, maybe
no. Because we were discussing about it, I was also trying to understand how it can help us. So that's why I'm asking you, because you have played with it. So
right.
Can I ask a question there? So from my understanding, it works great if you have most of your queries are in what we would call the latest partition, because they are doing a lot of work to keep the latest partition in memory. And
right.
So if we don't have that case, so for example, we just partition webhook logs by date. And in the case of webhook logs, we always query the last 7 days. In that case, I assume that TimescaleDB will be perfect. But for all other cases, if we want to do, normal partitioning, let's say tenant partitioning or whatever, where you don't always access the last one, would TimescaleDB be useful for those cases, or it will be only for the case where we have, the time data, the time constraint data.
Well, it's a good question. Actually, if we, first of all, about cache, I don't think the only case when timescale or any time-based partitioning works well is when you access the only fresh data. Postgres caches pages, not whole table, right? So we can cache some old partitions partially and still benefit from it. It's kind of it makes better maintenance tasks like index recreation, auto vacuum, because we can parallelize it and utilize more cores to process one single big entity. And but with respect to cache, it's page level. So I don't think you cannot query old data. But of course, like with timescale and any like time series approach, I would say it's not about selects, it's about updates, and maybe deletes. It's not like it's working less and less well if you update all data a lot or delete all data, to not just prune partition, like dropping it completely, but you need to delete some partition records.
Did you say, sorry, clarify, did you say it works less well if you're constantly updating rows?
Right. Okay. Right, because it's like updating rows, especially if you, for example, you need to update some old row and your update is moving to different partition. This is the worst case.
Okay.
So, but the same thing for time-based partitioning in Postgres. For not time-based partitioning, it's timescale guys open their talks. I saw it, like they say all data in the world is time series data. This is like interesting saying. I'm not 100% convinced, but it's interesting to think about it in this case. So, but if you think about GitLab data, most of data has of course not everything, but especially big tables where we have a lot of data. It's produced over time, so we can think about time series.
Yeah, but that's not the case if we start if we want to shard or partition by namespace, for example, or do tenants.
Exactly.
That's
right.
why I'm asking. I'm
right.
trying to understand and say that, for example, for those cases, it's not useful. But for the time decay, and you're right, we have, for example, created data everywhere. So
right.
if we always use, let's say, created that, and we always query for the last month or something like that, we always have a filter. I understand that. But for the other cases, this is not the case. Am I right?
Well, yes, like two things here. First, if we think about using, for example, project ID as time, like as a single dimension to partition, and think about it as time, it will be not a good idea, I think, because we cannot. There is no very old tail that we could compress or even delete, so it's not very beneficial, right?
There is no bias in the dimension. So the time
right.
has a very inherent property. It has bias. So there is nothing to say that smaller project IDs will get less updates than larger project IDs. So it doesn't have this intrinsic inherent property.
Well, maybe there is some correlation here. If project ID is very old, maybe this project already dead, like there is some correlation, but I'm not sure. Like it's like kind of I agree with you. Like it's very different.
Yeah, you're right. There is a bias, but there is no certain causality there. Like for example, if you have Stan who has a very old user ID, it's not like he will have less updates.
Right. I agree with you, right? And but it's about all time series partitioning. I know some people tried like to think about like let's take time scale because we want to deal with partitioning because it still needs a lot of things to implement, like pruning and management of partitions, right? So let's take it and use it. It's not a good direction to use it. But they also have second ability to create second dimension for partitions. So if it's not time series, time decay data at all, probably not a good idea. That's why I'm not pushing this as a tool for sharding, right? I probably will raise it a little bit later if we start thinking about sharding parts of database, so vertical sharding, so-called, right? So if we go this direction, we can take part of database which truly has time series nature, right? Like CI data. In this case, maybe it will be interesting to consider the time series or the time scale. So right now, I'm saying like why we develop time decay support ourselves. Why don't we use existing very good tool which is developed very well? So I see like a lot of activity around this project and a lot of users.
So can I ask here? So let's say that we want to use TimescaleDB. How easy it is? So what are the requirements for self-hosted instances and for us? If we say that, because whatever solution we're going to use, we have to be able to switch and use it both on GitLab.com and
right.
In a perfect scenario.
My answer is I think no restrictions, but I will check with who are experts in licenses. So as I know, no restrictions. We can use it on like 100,000 setups and just ship with it. It's quite free license, but worth checking.
And you can switch a Postgres database directly without any changes.
Say it again.
Sorry? And you can switch any existing Postgres database to
TimescaleDB. It's extension, right?
Yeah. So you don't have to rebuild. You just add the extension, or you have to. Yeah. Okay. That's.
So you create extension. This is what I did. This my snippet I sent to our chat. It should have. If it doesn't, I will like let me know where we discuss it, issue or something. I will put instructions how quickly try it. It's quite easy though. So we create extension, adjust the shared preloaded libraries, restart needed, of course, because it's extension which requires restart, and that's it. So we can create a so-called hyper table. They call it hyper table. So it's distributed table and start moving data there. Interesting question how to migrate online, but it's they don't provide tools for online migration, unfortunately. So you need to develop it. That's it. So like.
Yeah, but those are the tools that we already have. So if they can provide us with additional stuff, so why? And I agree. Why build additional? Tooling, but we have to understand what are the problems with enabling it, and is this this is a plugin that needs building, or is it supported by default? So self-hosted instance, so it's just a package and you're set to go.
Right. So interesting also question. I think so. We just install this extension, so it's easy. And what I wanted to say, I forgot. They also it has interesting time scale scheme, like information schema. You know, this like SQL standard API to understand like some meta information about database, like to see which columns tables have and so on. So they created their own like additional schema to expose some stats and so on about what is happening with data. This is quite interesting. Again, as I've said, if we even don't use it, at least study this interesting extension, which is actually already quite big company and big project, and learn something interesting from it for our own implementation.
So I got to drop off here in a minute. I got another meeting to run to. So I'll create an issue where we can discuss this. It doesn't sound like it's blocking our implementation of anything right now, but it's something we should discuss for accelerating any kind of time decay that we may want to do in the future. Is that right?
Keep me posted if anything needed. I will help.
Awesome.
Okay. Thanks.
Thanks for the overview, Nick. Thanks,
Bye.
Hannes.
Thank you, Nick.